There was a question over here earlier that we didn't get to.
Did you want to ask Robin her question?
Yeah, actually, she was showing that the moon was molten, I don't know for how long, but isn't that consistent with the fact that people are saying that the moon had magnetic field early on? So.
Did you hear the question, Robin?
Sure, yes. In truth, it's extremely difficult to avoid having a molten moon, as it is assembled very quickly after the giant impact, and the material that is accumulating to form it is still very hot. So it's almost impossible to avoid an initial fully molten state. Then the question is, over a time scale of 1 million or so years needed for the moon to encounter evacuation, is it partially cooled, and then does it remelt due to eccentricity excitation associated with evacuation? But certainly having a molten initial moon is the natural outcome of a giant impact. And yes, that is what you would certainly need or expect there to be an inner molten layer in order to have a dynamo at an early field, if there was indeed one.
Toshi Hirobayashi from Georgia Tech. I have a question for Bill. When you showed David Nesborny's simulation, you showed the impact of a solar system. I was wondering if you actually, or he got some simulation giving Borealis impact on Mars. Basically, that would be a good constraint on the dynamical evolution.
You said you wanted to know if he had what kind of impacts on Mars?
So like when you showed his simulation, you had the Earth system impact.
Yes.
Yeah. I was wondering, there is another impact on Mars, basically Borealis impact, which would be large enough to be able to consider, the dynamical evolution. So I was wondering if you could be able to give some like insight into it. Is that good constraint on the dynamical evolution?
I think so. Well, all right. So some models that David has just presented that I didn't show here, but David I think presented them at a workshop in Paris a few months ago. Some of his latest results are actually getting that there's sort of one last large projectile that sits out there to hit Mars. And the size of it is kind of what you would expect for something that would make the Borealis Basin, which is this 10,000 kilometer basin on Mars. It probably produced the global dichotomy. So just the fact he's getting something like that is fascinating. So that suggests maybe there's, again, this model is right on the right track. But what he also finds is he actually gets pretty good impact rates on the moon and Mars and can make a comparison. And if he's right, which I think makes sense, something to keep in mind for Mars, for thinking about the history of Mars. Right now, all the chronology that we use for Mars is linked to the moon. And so what people do is they take today's impactor populations on the moon and Mars, and they try to use the moon and use that to try to say, this is what Mars's history is based on the moon. But if everything hitting early on was leftover planetesimals, those models that we're using today are wrong. You have to completely revise the chronology. And we've done some of that, and I think we need to do more of that. But it could be that a lot of the early ages on Mars that people use that are thrown around by the Mars rover people and the rest, they may need all be revised. So
we have an online question here from Timothy. Do they think undisturbed samples of lunar regolith can be found and collected in order to conduct potassium-argon dating in order to test the magma ocean theory?
Oh boy, I think I'll right. I am not I lack the expertise to probably answer that question correctly. So I'm going to try to paraphrase things I've heard from Lars Borg. Okay, so Lars would say that we have this immense Apollo collection, but when you really take all the rocks and you look for the samples that really probe the earliest history of the moon and tell you about the magma ocean phase and what was happening then, it really comes down to about the order of about 8 samples or so. And everybody does work in these 8 samples trying to figure out what the earliest, what was the earliest history of the moon. But he would say that we're in desperate need to really make progress to get additional samples that really probe the early moon. So I don't know if we can get those from, let's say, getting regolith samples. I think we're going to probably have to choose them more carefully from that, just because of all of the Apollo rocks we brought back. Blars would say again, it's such a limited sample that's really probing that early history. So.
This is another one for Bill. Yeah, I know we keep putting you on the spot here. Anyway, you mentioned something in the modeling that you showed about a Neptune-size planet in the outer solar system that eventually gets ejected out.
Yeah.
Does that get completely ejected out in the sense it winds up on a hyperbolic trajectory, or does that actually wind up in a high elliptical orbit of some kind?
It probably gets completely ejected out, but there's some interesting issues around this, right? So this is not, we're not explicitly modeling this, but there are some people that model related things. And so for example, people think a lot about this planet X or planet 9.
Right. That's kind of why I was asking about that. Yeah.
So there's a lot one could say on this, and I'm going to try to just give you a quick summary. So the problem we have with getting a planet X is that when things are thrown out, they tend to escape. Your only hope of sort of capturing them is if you're in a situation where, like, say, a passing star is coming by, you might be able to circularize the orbit. And if we're in a star cluster, that actually can happen at about 10% of the time. But that means you have to throw out 10 things to have a decent chance that it happens once. So it's not going to happen to a Neptune-sized body. But there's some simulations that suggest that the outer solar system makes a lot of, let's say, Earth-ish or like super Earth-ish type bodies. And you might throw out 10 of those, and then one of those might be captured. The mass they're suggesting now for Planet X is about that size. And it's not so crazy because some people suggest, for example, that Uranus is tipped over because it was hit by an Earth-sized body. So maybe there's an interesting story there that needs to be go forward. So that's, I think, to pull some of those things together, I think that's what's going on. Those size bodies wouldn't really affect the results I showed here, though. So I think that's okay.
Sure, interesting stuff. I never thought about that at that stage in the early solar system. You're also, the sun just a few steps away from being probably in an open cluster kind of formation. So yeah,
it's amazing how much we have to think about these issues when trying to think about the early solar system history. That you really have to start to worry about all this kind of stuff, and that yet there still might be constraints if we're smart that can help us tell what happens.
Sounds great. Thanks.
Yeah, we have time for one more quick question. Oh, boy.
Really? Is that it?
Well, it's 4 minutes until the start of the next session, which is
okay.
downstairs. So
That was fast.
who has the quickest question?
Yeah, just hand up first.
Okay, go for it.
The room is mic'd, right? So we can. So, Bill, something that might help when, the arguments about the age of the basins and, we really only know Imbrium or, maybe we know Chrysium or maybe we know Nectaris. Going back to the work of Terra and Wasserberg et al. Early on, they were looking at a disturbance in the lead system for highland rocks and argued that there was evidence of a pervasive disturbance between 385 and 4 billion years.
Yeah.
And then looking at other isotopic systems, they actually made the argument that maybe it was sporadic from the beginning, from the origin of the moon and then finally terminating in 3.9. I just wondered if you had any thoughts about this and the sporadic or sporadicity, is that a word?
I think having some kind, right, the problem is this, right, is that from my memory of even talking to Jerry Wasserberg about some of these things, is that, like he would say these things are absolutely clean, that we have an age of 3.9, there's not much before that time. It's just hard to imagine the moon having nothing else going on. So, I mean, I have to think, so if you're seeing sporadic upsets of the system, that to me makes sense of having other impacts take place. In fact, there's even some arguments that there was a pre-existing basin exactly where Imbrium formed today. And so that pre-existing basin, when Imbrium formed, put a lot of that material all over the near side. And that might explain some of the interesting like 4.1, 4.2 ages we have. I've seen people like Mark Norman argue for that. But essentially, when we go to these conferences, it's hard to get a consensus. And I think ultimately we're going to have to get more samples to really really be able to go forward. And so bring on endurance, right? So
More sample.
more samples, yeah.
All right, let's thank our speakers again.